So this video is trying to give a short derivation of the Stirling's approximation, or people like to say Stirling formula. Basically, just use n factorial well close to 2 pi root of square n, n to the n divided by e to the n. So this Stirling formula is widely used in statistical mechanics, statistics, and probability theory. Okay, or even in analysis. Okay, so key point is that the key point is that what we want to prove this. Okay, so the easy bound, the easy approximation to n factorial is you just take long, then it's gonna be long 1 plus long 2 up to long n. So you can write it as k from 1 to n long k, and then you can approximate it to be long x dx and 1 to n, and this can be done by integration by part. So this is your standard integration by part. So you will get long n times log n and minus what? Minus n. So you will get log n to the n divided by e to n. Okay, so the easiest approximation is here. Okay, so usually this is already very powerful computation. Okay, and another what we need to prove, what we need to show is the more complete one. Basically, you contain this, but you can see when n goes very large, then this term will dominate this term, because this is n to n. This is 1 over square root 2 pi n. So this is already a very good approximation. And this is, I guess, this is the I should say extremely good approximation. Okay, so now the next step is we try to prove this. So to prove this, what we need more calculation. Basically, we need to start from this one. Okay, so this is from the gamma function. Okay, so I will have some videos describe the properties of gamma function in the future, but basically you can just follow the definition of gamma function and prove it by yourself. Okay, so this is not so difficult. Okay, but what we like to do is do some manipulation on this kind of term and try to manipulate it. Okay, so I want to take a long on this term, so I get n long x minus what? Minus x. Okay, and I want to let x equals to n plus some delta. This should be right as per c. Okay, so I call it per c, but probably I shouldn't call this. Okay, so n plus per c minus n minus per c. Okay, so key point is that we will do the integration on dx, but we pick this function at x equals to n, and then we try to do the integration on the per c. So basically, you can view as we just do the change of variable. Okay, so up to this data, we just do the exact computation. But then from here, we do the standard Untitled expansion. So we have this. Okay, and what we need to use is long 1 plus x is close to x minus x squared divided by 2 plus x cubed divided by 3. So what we use is the first two terms. So we have n times long n plus long e plus eta minus n minus eta. So this term can be written as let me see. First term is still long n. The second term is eta divided by n. minus eta squared is 2n squared minus n minus eta. So the first term is this, the second term is eta. So these two terms cancel. Okay, and minus eta divided by 2n. Okay, so the integral from this basically is this one. After we change a variable, then we get so this x to n exponential x long is equal to this. So you can take exponential, you get n log n times exponential minus eta squared divided by 2n. And remind that and the integral is still infinity, but since x is from 0 to infinity, and with that x equals to n plus eta, so this is minus n d eta. Okay, I think this is the hey, oh, there's a minus n term here, so still minus n. Sorry about that. Okay, yes, okay. So we'll have 3 terms. Okay, and the key point is that we want to do the integration along this eta. So this is we approximate n to be infinity, since we want to take the largest n. So the integration, I will change the integration to be this. Okay, so this term is basically log n minus n, this one. And then this is the Gaussian integral. So let me tell you the result. This is pi divided by a, if a is larger than 0. Okay. So from here, what we have is exponential n times log n minus exponential n. This is square root of 2 pi n, 2 pi n. And this is n to the n divided by e to the n, and square root of 2 pi n. So basically, it's close to n factorial. Okay. So basically, this is the proof. Okay. So yes, I think this video is up to here, and I think it's very interesting and very elegant formula. And I will see you guys in next videos.